Yes, good evening, guys. Once again, I will go through the practical experiment that you had. Here you see what we're talking about. It's about the process. Experimentation 1. Okay? So I'll go once more to the plants that all of you know. To remind you what you need to know for your test in a few days. Anyway, it's dark. I'll start from here. What do we have here? Number one, we have a compressor. Okay. Then we have a control tank. Down you see there. At the bottom, we have a storage tank. On top there, we have a capacitor probe level sensor. Down there, we have a pump. Next to the pump is a pressure sensor. Then next to the pressure sensor we have a magnetic flow meter. Then here we have a control valve. Look on the other side. What else you need to know? We have a filter there. Okay. An air filter. Next to the air filter is an air regulator. Then on the control side we have an AC bridge down there. Underneath I have a controller which is an Arduino Mega. The black device there we call the signal converter. It's dark, I'm sure all of you guys know it. The signal converter. Next to it we have a transformer. That one also is a transformer. Then downstairs you have your PC. This side is your PC, laptop. This side is the control side. Quickly, I wanna go through the device, each device, and tell you what the purpose. Number one, I'll come back here to the compressor. The compressor normally is the one that compresses air and turn it into pressure. Okay, then pressure flows through the air line. When it reached before the air filter, we have a hand valve because sometimes can stop the pressure from coming. So the purpose of the air filter is to remove any dust, impurity, or moisture in the air. Remember, when you compress air, it's weight, so can find still some water. To remove water, impurity or moisture, you have to use an air filter. Next to the air filter, we have air regulator. Why do we need an air regulator? If you come here and check on the nameplate of your control valve, as you see there, it says that the maximum supply pressure this valve can handle is 800 kilopascal. So for us to achieve that, for us to protect the device, we need to have an air regulator. So from this air regulator, even the air from the air filter or the pressure from the air filter, for example, is 1000 kilopascal, and the air regulator must always give you a maximum amount of pressure of 800 kilopascal. Okay, then next I'll talk about the capacitor probe level sensor. However, is dark, but if you see inside, we have two probes. One with the white insulation is the probe of the capacitor, and next to it, you see that there's a strip metal. Okay, so what happened or how it works? Normally, you have a plastic tank, okay, where the water is stored or is controlled. When the level or when the tank is empty, there is a capacitance in between. The capacitance is created between the probe, the metal probe, and the capacitor probe. That capacitance normally also inside the probe we have air, has your dielectric. As the level of water increase, it short circuits the area of the capacitance, and the change of area induce a voltage output. So the change of the area of the capacitance also induces a change of the dielectric inside. And that change of dielectric normally produce an output signal, which is voltage. You guys have to remember that normally that signal is 0 to 2 volts. But for the instrument to work, we need a supply. So the power supply for capacitor probe level sensor is 20 volt DC. Okay, then I'll go on the other side. Need to be faster. Okay, the pump is your pump, electric pump. The purpose of the electric pump is to pump water from the storage tank to the control tank. For the pump to operate or to start pumping water, it needs to be powered. And the voltage supplied to the pump is 230 volts AC. Next to the pump, we have a pressure sensor. Okay? You guys, some of you understand how a pressure sensor works. It has a diaphragm. Then there's a crystal on top of the diaphragm. Also, it must have some kind of amplification, okay, on top. So, as water flow or as pressure increase in the pipe, the diaphragm defect. That defect now will cause, okay, property change on the crystal, which will induce a voltage. That voltage is amplified, then converted to current. So the output signal from your pressure sensor is current, which is 4 to 20 milliamps. But the power supply or the power supply signal or the voltage used to power your pressure sensor is 24 volts. The whole connection is done in what is known as loop power, because I'm sure you know what is loop power. Next to it, you have a magnetic flow meter. The magnetic flow meter is made of a coil. If you see there, it's down there, there is a coil. So, and on top of the display, the coil, once it's powered, and the supply voltage to the magnetic flow meter is 115 volts. Once you power your mag flow or magnetic flow meter, the coil will induce a magnetic field. Okay, remember that coil is a primary and secondary part, the winding, two coils. It induces a magnetic field, but now, any time that there is a flow across, or any time that the flow cuts the magnetic field, what happens? There is voltage induced. That voltage induced is how a signal output from the mag flow or magnetic flow meter. Magnetic flow meter got two outputs. One is voltage, which is 1 to 5 volts. The other signal output is current, which is 4 to 20 milliamps. Next is your control valve. Control valve normally has two parts. The top one is your valve positioner, and the bottom one is the valve itself. Okay, valve positioner then and valve bottom. How this operates? The valve positioner needs to receive two signals for it to let the valve to pull up or down. One signal is a pneumatic signal, which is air, and another signal is current signal, which is 4 to 20 milliamps.